Okay, I just wanted to go over a quick calculation where you can actually use that heating curve to kind of help you keep track of where you are in the problem. This is a challenging heat calculation because it involves multiple steps, right? So I'm going to read you the problem and kind of just explain to you how I knew that in the first place, and then we'll go over which formulas to use where, okay? So it says a 12-gram ice cube at -4 degrees Celsius is placed in a glass of water where it melts, okay, and reaches a temperature of 25 degrees Celsius. So you're starting here at the solid ice cube, and it's increasing temperature, and then boom, at 0 degrees we know ice melts, and then it doesn't stop there because it continues to increase in temperature to 25 degrees Celsius. Okay, so the melting happens all at 0 degrees. Anytime you have a temperature change, remember, you're using Q equals MCAT. Okay, and anytime you have a phase change, you're looking at either mass times the heat of fusion or mass times the heat of vaporization. Okay, the heat of fusion could either be positive or negative depending if it's melting or freezing. Same with that heat of vaporization. Okay, so I kind of go through and get myself organized before I even deal with the calculation. So remember, anytime you are increasing in temperature, that is the formula that actually can accommodate your change in temperature. So Q equals specific heat times the change in temperature, and Q equals mass times the specific heat times the change in temperature. And then anytime you have a phase change, you're not having a change in temperature, so you're going to be using one of these. Q equals mass times the heat of fusion or heat of vaporization. Melting and freezing uses the heat of fusion. Melting, more specifically, gives you a positive heat of fusion. So at this phase, you're going to do M times the positive heat of fusion. Okay, so then you just go and do these three calculations and add up the sum of your Q's. Okay, so think about, as you're melting, that is an endothermic process, so you can kind of anticipate that your Q's are going to be positive. And right here as well, you use your positive heat of fusion. Okay, so my first equation, Q equals mass times specific heat times the delta T. I am going to pull up these charts that I have in another packet. Okay, so Q we don't know, we're solving for. Mass, it told me in my problem, 12 grams. Specific heat of water. Okay, so I have several specific heats here. And for water, I'm going to pick water as a solid. So 2.110 times my change in temperature. And remember, it's very important that you're doing T final minus T initial. Okay, because it's not the absolute value of your change in temperature. The sign does matter. Okay, so my final temperature is 0. My initial temperature was -4. 0 minus -4 gives you a +4. Okay, so then you want to calculate that out and just put a little pin in it. (101.28 joules). Okay, that's of my first increase in temperature. My next step is Q equals the mass times the positive heat of fusion because I'm melting. So Q equals 12, still 12, nothing's gone, times the heat of fusion for melting. Okay, so 334, and I'm using a positive 334 because it's melting. So 4,008 joules right there is absorbed because it's positive. Okay, Q equals specific heat times the change in temperature again, I'm still at 12. Now the specific heat of water changes because it's phase dependent, remember. So water as a liquid specific heat is 4.184. And my change in temperature for this would be going from 0 to 25. So final minus initial, 25 minus 0 gives me 25 joules. I'm sorry, 25 degrees Celsius. Calculate that out. 12 plus 4.184 plus 25, 41.184. Okay, so the total heat absorbed when you add all those together, you just simply add them up. Q equals positive 4150.464. In sig figs, I am stuck with 2 from that 25 degrees Celsius. So plus 4,200 joules. Okay, so this is endothermic. And we know melting is endothermic. And that means it absorbed energy. My Q is positive. And that is about as complicated as it will get. Don't do this if you're only on one line on your chart. All right.